Good morning, this is Dr. Turner for Integrated Math 3. Today we're going to be talking about 8.2, which is using trigonometric ratios. Now we're actually getting into using the trigonometric ratios that we introduced in 8.1. This is going to be a lot of calculator work for the most part, but pretty straightforward. If you haven't watched 8.1 yet, you probably want to go back and take notes on that first so you know how to set these up. And then from there, it's pretty straightforward. So let's go ahead and jump right into it. So in 8.2, we are looking at, again, using these ratios. Just a really quick reminder, and this is in 8.1, but if I'm looking at a triangle, then I have three sides, of course, and from a given angle, call it theta usually, that Greek letter that we talked about, from any given theta, you have three sides. You have your opposite side, you have your adjacent side, and then you have your hypotenuse. So if I know the angle measurement, so instead of theta, if I put a 20 degrees there or 30 degrees there, if I have that information and I know one of the sides, I can find the missing side using my ratios. Now, we've looked at right triangles before where we're solving for missing sides, right? We've used Pythagorean theorem in Integrated Math 2, Integrated Math 1, Math 8. But now we're only given one side. So if we want to solve for a missing side, we need to know an angle measurement. So this is what it's going to look like. And again, bear with me on the crudity of the drawings there. But let's say this is my triangle. Something like this. Remember to pay attention to which angle is given. It's not always going to be the one in the bottom left corner, especially if the triangle is oriented differently. But let's say that's my triangle, 90-degree angle. Let's say I say this is 25 degrees. Let's say I want to know the opposite side, but I know that the hypotenuse is 15, for instance. Okay. So we're trying to solve for x here. Now, I know an angle. I'm trying to solve for the opposite side, and I have the hypotenuse. So you're looking for which of those three trig ratios that we talked about is going to relate those three pieces of information. So looking at this angle, we have the opposite and the hypotenuse. That's sine. So our setup is going to be sine of 25 degrees is equal to the opposite sine, x, over the hypotenuse, 15. To solve this is a cross multiplication problem, so I can put a 1 underneath my sine value. And then I'm going to cross multiply. I get x equals 15 times the sine of 25 degrees. Okay. That's basically our answer. Now, we want to write this as a decimal value, so we're going to need a calculator. I know that a lot of you are still kind of using either your phones as a calculator, or maybe you have like a basic calculator. You want to be using either Desmos if you're doing it online, or you want to be using an actual scientific calculator, either Casio or TI. But a decent one, I highly recommend that you use one that allows you to just input your line and then hit enter rather than having to work the problem backwards, because that can get confusing. It's more common that students make errors with those types of calculators. And if you need to, I can recommend one. They don't cost much. They're $8, $9, something like that. So right now I'm using Desmos, so I'm going to calculate, tabbing back here, I want 15 sine of 25 degrees. Well, one thing to keep in mind with most calculators, but especially Desmos, that is, if you look at the settings for Desmos specifically, at the very bottom you see what's called radians and degrees. Just like we measure temperature in different ways, Fahrenheit, Celsius, Kelvin, angle measurements can also be measured in different units. Radians is most common when you get into higher level math and when you're graphing especially, but for us right now, we want this in degree mode, so you need to make sure this degree button is pressed. If it's not, you're going to get something entirely different. Just as an example, right, I want 15 sine of 25 degrees, which gives me 6.339. But if this had been in radians, I'd have got negative 1.985. So way off. So make sure your calculator is in degree mode. If you're using a physical calculator, at the very top you should see either DEG and the little tiny text at the very top line, either DEG for degree or RAD for radians. If you have, let's say, RAD set for some reason, you can either reset your calculator to the factory settings, or you're looking for a button that says DRG, which stands for degrees, radians, gradients, which will switch between those three modes. Okay? So make sure you have that set up before you continue. But that's pretty much it here. We're going to set up the ratio, and then we're using our calculator to solve. So let's look at another example. Number 2. Again, the triangle can be oriented anyway. It doesn't have to be always facing the same way. But number 2, let's say it's facing this way, which means my right angle is right here. Let's say this is my theta. I want to solve. Let's say this time I have this side as my unknown, and I have this side as 6. So, given an angle measurement, let's say theta is 32 degrees, I want to solve for x. So the setup, I'm looking at an angle, I'm looking at the hypotenuse, and I'm looking at the adjacent side because it's touching my angle. That's cosine. So cosine of 32 degrees is equal to the adjacent side, x, over the hypotenuse, 6. Then I cross multiply, and I get x equals 6 times cosine of 32 degrees. From here, this is calculator work, so I'm going to tab back over. 6, remember to make sure it's in the correct form, 6 cosine of 32 degrees gives me 5.088. For my classes, remember that I'm asking you to round to the nearest thousandths place, so 3 decimal places. Pay attention to what directions say, though, on a standardized test. It might ask you to round to the nearest hundredths, or the nearest tenth, or it might say nearest whole number. So pay attention to the directions there. So hopefully this is pretty straightforward. Now in these 2 examples, when I set up my ratio, I ended up having my variable on the top. That won't always be the case. So for instance, number 3 here, say I have an angle of 80 degrees. Let's say I have a side of 20, and I want to find the adjacent side. So for that angle, I'm looking at opposite and adjacent. That ratio is tangent. So my setup would be tangent of 80 degrees is equal to the opposite side, 20, over the adjacent side, which is x. Now my arithmetic's going to be the same steps. However, in this specific example, when I cross multiply, I'm going to end up with a division problem rather than a multiplication problem. So you would cross multiply, tangent of 80 degrees times x equals 20 times 1. And then to get x by itself, you would divide by tangent of 80 degrees. Remember, sine, cosine, tangent of a number is itself a number. It's typically going to be a decimal value, but it is a number. Once we get x by itself, we'll pull up our calculator, 20 over tangent of 80 degrees, and we get 3.527. So here, x equals 5.327. I got this space down here. Let's try to do one more. Number 4. Number 4. Let's say I have an angle of 40 degrees. I know the opposite side is 12. I want to find the hypotenuse, which is my x. So I have an angle, opposite, and hypotenuse. That's going to be sine. So sine of 40 degrees equals opposite over hypotenuse. Cross multiply, sine of 40 degrees times x equals 12. Divide by sine of 40 degrees, I get 12 over sine 40. From there, calculator work. So 12 over sine 40, 18.669. And that's it. If you guys have any questions, please reach out to me. Otherwise, have a good day. I will talk to you soon. Bye.